Okay, now let's look at plotting complex numbers. This is a very easy problem. It's just something you know how to do. So remember, let's review complex numbers. Complex numbers are written in the form a plus bi, where a is called the real part, bi is called the imaginary part. Let's look at an example. Let's do 6 plus 4i. If you have 6 plus 4i, then what we have is we have a is equal to 6 and b is equal to 4. Now, b is kind of an interesting number, right? What b is b is the number of imaginary units. So the way we're going to plot this, well, obviously we can't plot this on an xy graph because the xy graph, both x and y are real numbers. So what we're going to do is we're going to plot this on two graphs. We're going to plot this on a graph with two axes. And the horizontal axis, which in a kind of a normal graph is the x value, is going to be the real number line. I'm using r as just a symbol meaning real numbers. And 1, 2, 3, 4. This is just your old number line that you learned in, I don't know, 2nd or 3rd grade, right? So here, to know 6 real units, you'd go 1, 2, 3, 4, 5, 6. That's where you'd go for 6 real units right there. I'm even going to put a little 6 there. Now this axis, the vertical axis, is going to be the imaginary axis. It's just like a real number line, except for each unit is an imaginary unit. And just like real numbers, you can go in a positive or negative direction. In the imaginary units, you can either go in a positive or negative number. And actually, this distance between any two tick marks here is defined as I. So I is called the imaginary unit. And you can just, it's sort of like the imaginary one. 1 is a unit, and I is the imaginary unit. So here, what do we have? We have 6 real units, so that's 1, 2, 3, 4, 5, 6, and we have 4 imaginary units. This positive, so you go positive direction, 1, 2, 3, 4, and you simply read across. And in that sense, it's read across exactly the same way as it is in x and y graph. So that's how you graph 6 plus 4i, right there. Let's plot another one. Let's plot a couple. Let's plot minus 2 plus, let's do 5i. Well, what's the real part? The real part is the minus 2, so that's negative 2 real units, so that's right there. And the imaginary part is 5i, so that's 5 imaginary units. Are they positive or negative? There are 5 positive imaginary units, so that's 1, 2, 3, 4, 5, and you simply read across. So that point right there would be a minus 2 plus 5i. Let's plot one more, and then we'll start working on some tricks. Let's plot 3 minus 4i. No, we already did 4i. Let's do 3 minus 6i. The real part is 3, so that's 1, 2, 3. There's 3 real units, and then they're positive units, and that's a negative 6. That's 6 imaginary units, but they're negative, so that's 1, 2, 3, 4, 5, 6. So that's 6, or you can think about it 6i if you want to. And that's that point right there, 3 minus 6i. And that's how you do it. Now, there are a couple tricks. Let's say you wanted to plot, for example, 4. Well, 4 is a real number, so what is the imaginary part of 4? None. So the important thing is that the 4 that you've seen ever since you were probably 2 or 3 is really just 4 plus 0i. Where's 4 plus 0i? 1, 2, 3, 4. There's 4 right there. So that's 4, or 4 plus 0i. Let's plot 8i. 8i. What's the real part of 8i? The real part is 0. What's the imaginary part? 8 imaginary units. They're positive units. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's 8i right there. And that's how you plot plot complex numbers. In the following video, there's a video that's called Find the Absolute Value of Complex Numbers, and that uses this plotting.